Chapter 3: Motion of the Earth. In the previous classes, we have learnt that the Earth is one of the 8 planets. One of the important characteristics of the Earth is its movement. Seeing the Sun move through the sky is a result of the fact that the Earth rotates on its axis. As with all planets in our solar system, the Earth orbits or moves around the Sun. The Earth's axis is slightly tilted with respect to its orbit around the Sun, resulting in the change of seasons. The Earth also follows the Sun in its motion through space. Its motions result in days, nights, seasons and years. Motions of the Earth. Like other planets, the Earth also has 2 types of motions: rotation and revolution. Rotation is the movement of the Earth on its axis. The Earth spins on its axis from west to east, counterclockwise. It takes the Earth 23 hours, 56 minutes, and 4.09 seconds to complete one full turn. Day and night are produced by the rotation of the Earth. Revolution: the movement of the Earth around the Sun in a fixed path or orbit is called revolution. The Earth revolves around the Sun, in a counterclockwise direction, once every 365.25 days. Its velocity in space in its orbit is about 18.5 miles per second. What would happen if the Earth did not rotate? The portion of the Earth facing the Sun would always experience day, thus bringing continuous warmth to the region. The other half would remain in darkness and be freezing cold all the time. Life would not have been possible in such extreme conditions. Rotation of the Earth: on every morning, we see that the Sun appears in the east. With the passage of time, it seems to be moving from east to west. The Sun becomes brightest at noon. The sunset brings evening. In fact, it is not the Sun but the Earth which moves. Why does the Sun appear moving? We can understand that easily if we try to recollect traveling by a train. As we look out of the window of the moving train, we feel as if the trees, electric poles, huts, houses, etc. outside were all running in the direction opposite to our travel. However, everything we see is stationary. That is just an illusion. In the same way, the Sun is stationary, but it appears moving because we are on the train, Earth, that is constantly moving, rotating. Revolution: the second motion of the Earth around the Sun in its orbit is called revolution. It takes 365 and 1/4 days, 1 year, to revolve around the Sun. We consider a year consisting of 365 days only and ignore 6 hours for the sake of convenience. 6 hours saved every year are added to make 1 day, 24 hours over a span of 4 years. This surplus day is added to the month to February. Thus every 4th year, February is of 29 days instead of 28 days. Such a year with 366 days is called a leap year. Find out when will the next leap year be? A year is usually divided into summer, winter, spring, and autumn. Seasons change due to the change in the position of the Earth around the Sun. Orbital plane: the axis of the Earth, which is an imaginary line, makes an angle of 66.5 with its orbital plane. The plane formed by the orbit is known as the orbital plane. The Earth receives light from the Sun. Due to the spin of the Earth, only half of it gets light from the Sun at a time. Circle of illumination: the portion facing the Sun experiences day, while the other half away from the Sun experiences night. The circle that divides the day from night on the globe is called the circle of illumination. This circle does not coincide with the axis. The Earth takes about 24 hours to complete one rotation around its axis. Earth day: the period of rotation is known as the Earth day. This is the daily motion of the Earth. Change of seasons: the Earth's revolution causes the change of seasons. On the 22nd of December, in the north, it is winter. The southern hemisphere is inclined towards the Sun. The days here are longer and the nights shorter. In the northern hemisphere, the length of the day is the shortest. After 6 months, the position gets reversed. The northern hemisphere now has summer. The rays of the sun are slanting in the southern hemisphere. So it is the winter season there with nights longer than the days. Remember that the direction of inclination of the Earth's axis is the same in both positions. The two other positions relate to the dates the 21st of March and the 23rd of September. The Earth is nearest to the Sun at both these positions. In the northern hemisphere, by the March 21st, winter is over. The season is spring. It is neither cold nor not, and the days and nights are of about equal duration. The season is moderate, neither hot nor cold. In the northern hemisphere, the summer is over and it is time to prepare for the approaching winter season. Every year on the 21st of June, when the day is the longest, is called as summer solstice. In the same way, the 25th of December, when the day is the shortest, is called summer and winter solstice. The 21st of March marks the day when the day and night are of about equal length. That is called spring equinox. The 23rd of September is called autumn equinox. When it is spring in the northern hemisphere, then autumn in the southern hemisphere. Thus, we conclude that days and nights as well as the seasons change because of the rotation and revolution of the Earth, respectively.